In this video, we are going to look at the worksheet on isotopic notation. And so we're going to start by filling in the table that is on this worksheet. And with this part of the worksheet, we are given a isotopic notation, and we need to provide the atomic number, protons, neutrons, electrons, charge, and mass number based on the isotopic notation that is given. And so we start by needing to remember what the different pieces of isotope notation are. And so the number at the bottom, of course, is the atomic number. And then the number at the top is our mass number. So I always like to start by labeling the first one just to help me remember which number is which. And then if we had a charge, it would go up in this corner here. The fact that there is no charge means that this element must be neutral. It's not an ion, it's just a neutral atom. So let's start. We already labeled the atomic number, so of course that's 33. And we know that the atomic number is the same as the number of protons, so the number of protons is also 33. To find our number of neutrons, we need to look at our mass number. Our mass number is equal to protons plus neutrons. Mass number equals P plus N0. So to find our number of neutrons, since we have our mass number and the atomic number, we can just do the mass number and subtract out the number of protons. So 75 minus 33, and just to be sure that we get this right, we could use a calculator if you want to, or you can do it in your head. So 5 minus 3 gives me 2, 7 minus 3 gives me 4, so there are 42 neutrons here. And then number of electrons. Since arsenic here has no charge, we know that the number of electrons must be equal to the number of protons, because protons are the only other charged particle. So since there's 33 protons, we have 33 electrons as well. Our charge would be 0 to indicate that it's neutral, and our mass number, of course, is 75. Going down to the second row, we have magnesium. Its atomic number is 12. The number of protons will be equal to the atomic number, so that's also 12. The number of neutrons, of course, we can do mass number minus atomic number, so 25 minus 12 gives us 13 neutrons. Our number of electrons must be equal to our number of protons because there is no charge on magnesium. So our protons 12, electrons must also be 12. Our charge, of course, is 0 again, and then our mass number is the number at the top, 25. Down to carbon. Carbon's atomic number is 6, which means it also has 6 protons. Its number of neutrons we can find by doing mass number minus atomic number, so 12 minus 6 gives us 6 neutrons as well. And since there's no charge, the number of electrons has to be equal to the number of protons. 6 protons, 6 electrons. Once again, there's no charge, so that's a 0, and then the mass number is the number at the top, which is 12. Down a row, we have carbon again, so its atomic number is still 6, still has 6 protons, we just have a different isotope. This time we have carbon 14 instead of carbon 12. And so the number of neutrons of carbon 14, 14 minus 6, which gives us 8 neutrons. Again, there's no charge, so our number of electrons must equal our number of protons. So that's 6, the charge is 0, and the mass number is 14 this time. And I want you to note that between these two isotopes of carbon, the only number that is different is the number of neutrons and the mass number. Everything else about these isotopes of carbon is the same. Same number of protons, same atomic number, same charge even. They just differ by the number of neutrons, which therefore makes them have different mass numbers. Next we have potassium, whose atomic number is 19. That means it has 19 protons. To figure out the number of neutrons, we do 39 minus 19, so that gives us 20 neutrons. Our number of electrons, there's no charge, so we know it must equal our number of protons. So that's also 19, charge of 0, and our mass number is at the top, which is 39. Down to the next row we have potassium again, but this time we have an ion of potassium. Ion meaning that it's a charged atom. So still the same atomic number, still 19, same number of protons. We still have our mass number of 39, so we still have the same number of neutrons. 39 minus 19 gives us 20. But this time our number of electrons is going to be different. So if we have a positive charge, that means that we must have lost an electron. So we started out with the same number of electrons and protons. We started out with 19 electrons, but then we lost an electron to get that positive charge, which means that now we must only have 18 electrons. So 19 minus 1 gives us 18 left. So now we have 18 electrons in this potassium ion. And then, of course, our charge is +1. It's shown here, +1. And our mass number, 39. Moving this up just a little bit, we have copper. Copper has an atomic number of 29, which means it has 29 protons. We could figure out the number of neutrons by doing 63 minus 29, giving us 34 neutrons. Our number of electrons must be equal to the protons since there's no charge, so we have 29 electrons. Our charge is 0, and our mass number, of course, is 63, the number at the top. Then we have copper again, but this time we have an ion of copper, meaning it has a charge. Same atomic number, 29. Same number of protons, 29. Number of neutrons we still can get by doing 63 minus 29, giving us 34. And then our number of electrons is different here because we have a +2 charge, meaning that this copper atom lost 2 electrons to get this positive charge. So we started out with 29 electrons, but we lost 2, leaving us now with 27 electrons. And then that leaves copper with a +2 charge, and of course the mass number is still 63. On this next portion of our worksheet, we're supposed to use our periodic table to write the isotopic notation of each element with the number of neutrons mentioned. And so, since there's differing numbers of neutrons, we have different isotopes of each element. So here we have phosphorus with 16 neutrons, and then phosphorus with 17 neutrons. And so both of these isotopic notations are going to start with a capital P for phosphorus, and then phosphorus's atomic number, if you look at the periodic table, it's the whole number, and it's number 15. So that atomic number we know goes to the bottom of our isotopic notation. But then we need to figure out our mass number. So remember, mass number is our protons plus our number of neutrons. So we know our protons because our atomic number equals the number of protons. So we just need to do our atomic number 15 plus the number of neutrons provided. So 15 plus 16 gives us a mass number of 31. Which goes on top. 15 plus 17 gives us a mass number of 32, which goes on top. And since it doesn't tell us that these atoms have a charge, it doesn't tell us that they're ions, we are to assume that the charge here is 0, that they are neutral atoms. They don't have a charge. They've not gained or lost any electrons. Okay, so on to uranium. Uranium is symbol capital U. And uranium is number 92 on the periodic table. It's down in the F block, so I'm going to put 92 at the bottom. And then at the top I need to put my mass number. And I get my mass number by doing my number of protons plus my number of neutrons. And so I have to do 92 plus 143, which I am using a calculator to make sure I get my answer right. And that gave me 235 as my mass number. And then 92 plus 145 is going to give me 237 as my mass number. And once again, since doesn't tell us that these are ions, we are going to assume that they are neutral. On to carbon. We have carbon with 7 neutrons. Carbon symbol is a capital C. And carbon's atomic number is 6. So I'm going to put that 6 at the bottom, and then at the top I'm going to put my mass number. 6 plus 7 gives me a mass number of 13. This is carbon 13. 6 plus 8 gives me carbon 14. Then chlorine. Chlorine's chemical symbol is capital C, lowercase l. And chlorine's atomic number is number 17. So that goes to the bottom. And then to figure out the mass number, we do 17 plus 18, which gives us 35, chlorine 35. And then 17 plus 19 gives us 36. We have chlorine 35 and chlorine 36. Now, isotopic notation like this is the most descriptive way of showing what isotope we have, because not only does it show us the mass number and the chemical symbol, it also shows us the atomic number. And we can also show a charge if we have one. But we can also show isotopic notation or show what isotope we're talking about in a simpler manner, just by putting the name of the element. So for instance, chlorine. Then putting a dash and putting the mass number. So chlorine 36. And we could also abbreviate it by just putting the symbol dash mass number, Cl36. Chlorine 36, chlorine 36, or chlorine 36. Versus over here we would have chlorine 35 or Cl-35. So all these are correct methods of showing which isotope we are referring to. This next section says to draw the Bohr model that corresponds to the following. And so here we have chlorine with a -1 charge. So chlorine always has the same number of protons, and chlorine is atomic number 17, meaning that it has 17 protons. So we show that in our nucleus. I'm going to put P plus equals 17. Instead of drawing out 17 circles, I just put the number of protons equal to 17. And then, since it doesn't tell us what isotope we're talking about, we are going to assume that we are talking about an isotope with this same number of protons and neutrons. And this isn't always a good assumption. Really, it would be better if this sheet told us which isotope of chlorine we're talking about. And so for the sake of argument, let's go ahead and put some numbers here. Put a 17 there, and then 17 times 2 is 34, so we'll put a 34 up top, just so it's clear what isotope we're talking about. So our number of protons is 17, and our number of neutrons would be 34 minus 17, also 17. So I'm going to represent that with the N0 equals 17. Then our number of electrons. Now in a neutral atom of chlorine, the number of protons and electrons would be the same, but since we have a negative charge, that means that we must have gained 1 extra electron. So instead of having 17 electrons, we're now going to have 18 electrons. And of course our mass number is 34. So our last section here, we just need to fill in our Bohr model, and we can draw a whole bunch of dots, or we can just show the number of electrons that go in each level of our Bohr model. And so the first energy level, of course, can hold 2 electrons. I'm going to put a 2 there. This next energy level can hold 8 electrons. 8 there. And then our final energy level, we have 18 total electrons. We put in 10, so our final energy level can also hold the 8 electrons that we have left. Next we have magnesium, and it's magnesium 24. So that 24 is our mass number, so we'll go ahead and fill that in first. Our number of protons is going to come from the atomic number, which is 12. You could also find that by looking for magnesium on your periodic table. And then our number of neutrons could be our mass number minus our number of protons, which is also 12. So I'm going to put P plus equals 12, N0 equals 12, and then our number of electrons. Now we started out with 12 protons and 12 electrons, but then our magnesium atom lost 2 electrons to gain this positive 2 charge. So if we lose 2 electrons, now we only have 10 electrons left. So to fill that into our Bohr model, our first energy level will hold 2 electrons, and then our next energy level will hold the rest, the remaining 8 electrons. We don't even need this third energy level here. It's not in use. And then finally, we have phosphorus with a -3 charge, and this is phosphorus 31. Sometimes in isotope notation, you'll see that the writer of the isotope notation only gives the mass number and doesn't show the atomic number. So when this happens, it's easy to find the atomic number just by looking at a periodic table. So phosphorus, I found in my periodic table, and it has atomic number 15. So that means there's 15 protons. Our mass number is 31. And then we can figure out neutrons by doing 31 minus 15, which leaves us with 16 neutrons. And then our number of electrons, we started with 15, but then we gained 3 more electrons to get this -3 charge. So we start with 15, gain 3 more electrons, that gets us 18 electrons. And so if we fill in our Bohr model, we have protons, P plus equals 15, neutrons in 0 equals 16, and then to fill in our electrons, 2 go in the first energy level, then 8, and then the remaining 8 go in the outermost energy level. And so if you notice here, every valence shell has 8 electrons in it. And this is what happens when an atom forms an ion. That's why atoms form ions, is to reach a full octet in their outer shell. And so this is exactly what happened here. Phosphorus, if you look at your periodic table, initially has 5 valence electrons, and so it wanted to gain 3 electrons to get to a full outer shell. Magnesium had 2 valence electrons, so it wanted to lose those 2 electrons to get to a full outer shell. And chlorine, in group 17, already had 7 valence electrons, so it only needed to gain 1 electron to get to its full octet. And finally, we are given a Bohr model and asked to write the isotope notation and list the protons, neutrons, electrons, and mass number. So let's do this part first because that's easier. Number of protons is 11, it's given. Neutrons is 12. And electrons we can count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. And our mass number is protons plus neutrons. 11 plus 12 gives us 23. Now we need to write our isotope notation. And since this is not labeled with a chemical symbol, we need to look on our periodic table and figure out what type of atom has 11 protons. We're looking for atomic number 12, which is sodium. So for my isotope notation, I put Na. At the bottom, I put my atomic number, which is of course 11, and then at the top I put my mass number 23, and then I need to decide whether or not I need to put a charge. Now for there to be a charge of 0, we need to have equal numbers of protons and electrons, but in fact there is one more proton than there is electron. There's one more positively charged thing than there is negatively charged thing. So that means that my atom is going to have a +1 charge. Next up, we have 20 protons. Neutrons, we have 20 neutrons. And electrons, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 electrons as well. So our mass number, protons plus neutrons, is 40. And we need to figure out what type of element this is. 20 protons, looking at my periodic table, number 20 on the periodic table is calcium. So this is calcium. My protons or atomic number goes to the bottom, so I'm going to put my 20 there. And then my mass number goes to the top, calcium 40. And then I need to determine whether or not this calcium atom is charged. And I have 20 protons and 20 electrons, and since these are equal numbers, there's no charge. So I don't need to show a charge in my isotope notation. And then finally, this last one's maybe a little bit harder to see because you actually have to count the protons and the neutrons. So our protons are these black ones. We have 1, 2, 3, 4, 5, 6 protons. And then our neutrons are the purple. We have 1, 2, 3, 4, 5, 6, 7, 8 neutrons. And then our electrons, we have 1, 2, 3, 4, 5, 6. 6 electrons. So our mass number is just our protons plus neutrons. 6 plus 8 gives us 14. And now we need to write our isotope notation. So atomic number 6, that is indeed carbon. So I'm going to put big C. My protons, or atomic number, goes at the bottom, and our mass number goes at the top. And now we just need to determine if this has a charge. But we have equal numbers of protons and electrons, so there is no charge here. I won't show my charge.